Hello everyone. If you read that introduction we've posted with the video, now we can proceed to solve that slightly more complex example we've talked about. So here it is, what we will be doing. We should read a number, an integer n, from the console and then continue reading in the coordinates of n points. Further, we should calculate the area of a triangle which is constructed by those 3 points of those n points which are closest to the coordinate beginning. So I have wrote this program already so that you don't have to wait for me to type, but we're going to explain all of this now. So let's start. We've talked already about libraries, and this, for example, is one. But this one you shouldn't worry about because this is here automatically. It's just there because of the type of the project that I created in Visual Studio. So it doesn't really have to do with the functionality of the program we're writing, so do not worry about that one. These, however, I added, these two. And this stdio.h is there because in that library the printf and scanf functions that we used are defined, and we do not want to write these by ourselves. And also we are going to need some functions for calculating distances and areas, for which we will use a square root, which is the function is written in math.h. And all of these libraries have this h extension, which just means header. It's short for header. Okay, so you have read the text of the task. From that, it's obvious what we need to do. And the first thing we need to do is make this struct called point with elements that are just coordinates x and y, and we need this to use our points as any other data type. Okay, so we need two functions. One to calculate the distance between two points. It has these 2 points as parameters. Return type is double because obviously the distance doesn't have to be a whole number. And this just uses the formula for Euclidean distance, the simple square root formula. And see this function square root, it's defined in this math.h. I didn't write it. Okay, so we got that. Now we also need a function, I called it calculate area, which has 3 points as parameters. And what this will do, it will calculate the area of a triangle which is defined by 3 points, these 3 points A, B and C. So I use the Heron's formula, which just calculates the parameter and uses 1/2 of that perimeter to calculate the area. You can find the formula on Wikipedia, it's quite simple. So these distance of AB and of AC and BC, these are just lengths of the triangle's sides, which we calculated using this distance function we wrote, and this function returns the area of a triangle. Now, we haven't seen this before, but it's just important to know that this main is a function, like, well, almost like any other. It's not really complicated, it just has to be in every C or C++ program, because the program has to know where to start. It has to have an entry point. So this main, that's what it says. I'm going to start with the execution of the program here. The first line of the main is what will be executed first, and then continue towards the end of the main. And I'm going to separate these two lines because this get function, it's a native C function. Of course, I didn't write it. It's not even that important in a sense that it does something for these calculations we are going to make. I just wrote it because when you start a program, when it executes, the console it closes and you can't really see the result. It closes so fast that you can't see the result. So usually you're going to write something like this, or in other languages some read line or console.read line or read key or something, just that the program expects something and doesn't close, just so that we can see the result. We're not going to do anything with this. And this last line, return 0, it just means, the 0 means that the execution of the main went smoothly. There were no malfunctions or mistakes. The 0 tells to the program, okay, everything's okay. So that's it about the return 0 and these lines that do not have anything to do with actually the algorithm. They're just there to enable us to compile and execute what we want. Okay, so what do we have in the main? Our task said that we should read an integer n and later coordinates of endpoints, so we're going to do that. Here we declared an integer n, wrote this line for the user, a message to enter the number, and then we used the scanf function we talked about before to read that number. Now, we need an array of endpoints, so we need to save those points somewhere. And we haven't talked about declaring and defining arrays before, but it's not very complicated. We use this point. This is our struct point. See, we're using it as any other type. It could have said integer here. This is how you define an array. And we wrote 50 here, which means this array is going to have a maximum of 50 elements of 50 points. We're not going to enter 50. We're going to enter n, and the rest to 50 will just be some random values. Okay, so we got this array of points, and we also have one point. This point is also related to this variable coordinate beginning. This is a point, and this really could be anything, but it's usual to say that x and y are 0, that this is a standard coordinate beginning. Okay, so now again we write this message for the user so that he knows when he's supposed to enter the points, the coordinates. And this for loop, in this introduction we have said something about this, so this is going to execute n times. So for each of the endpoints we should scan and read its coordinates, which we are doing here. LF, we wrote about this before. This is a specification for the scanf functions of doubles, of the data type double, and LF is just long float. So it might make the memorization of it a bit easier. And we're just going through that user's input and reading in x and y of each of the endpoints. and writing them into that array we declared. Okay, so now we have saved all of the endpoints in the array, and since the task says we should calculate the area of a triangle constructed by 3 points that are closest to the coordinate beginning, obviously we need a way to find out which points are those closest, and we can do that by implementing a sorting algorithm on that array. So we sort the array and just take the first 3 points from the array, which will be the closest since we sorted the array in increasing order. And I'm not going to go into details here about this sorting algorithm because I just think it's a bit too soon for a beginner programmer to think about a sorting algorithm. These are, well, I can't say serious problems, but these algorithms can get quite complicated. So this one is simple, and even though I'm not going to explain this here, you can find it on the internet, on Wikipedia. It's called selection sort. And another simpler algorithm for sorting is called bubble sort. So bubble and selection are the two, let's say, easiest ways to sort an array, and you can look them up. There are quite a few animations and illustrations on the net explaining what they do. And I'm not going to explain that now for the reasons I stated already. But you should just know that after this point, after this line here, this array is sorted. And to calculate the area of the triangle, we are just supposed to call this function, calculate area, which has 3 points as parameters. And here, call them with these 3 arguments. Right now they're called arguments, and when you define the function they're called parameters, and here when you actually call the function they're called arguments. So our arguments are 3 points, array of 0, 1 and 2, so the first 3. Obviously in programming, counting and indexing of arrays starts with index 0, so do not forget that. Okay, so now we call this function, and it will just print the result, the area of the triangle, onto the console. And just this moment here, CLF for double, since the return type is double. But this 4.2, it's something we haven't seen so far, even though we use this printf function. But it's just to specify the precision, since we're talking about a double. So here we stated that we want only 2 digits after the decimal point. That's it. Okay, so we're done. And now the only thing left is to run our program. And in different environments you can do this with different buttons and shortcuts on your keyboard. Here it's F5. So here's that message we wrote. Let's say 5 points. And now we're supposed to enter the coordinates. So let's enter the coordinate beginning first, 0, 0, then continue with 0, 1, and 1, 0, and let's say 3, 2, and the point 1, 4. And this is my result, 0.50. So you can see that this is actually correct, since the first 3 points when the array is sorted are 0, 0, 0, 1, and 1, 0. And if you look at the coordinate beginning, the coordinate system, you'll realize that this 1/2 is actually the the result we were supposed to get. Okay, so that is it for today, for this example, and I hope it was clear and that you understood.